Hey everybody, Swarsky here. Let's go ahead and get into doing our last little piece of right and non-right triangles, and that is everything together. So put it all together with sine, law of sines, law of cosines, and trig. Okay? So that's going to be our job. Let's see what that looks like. Now, we have these three pieces, so we're just going to go over real quick when to use them because it's been a little bit. For trig, SOHCAHTOA, remember that sine is opposite hypotenuse, cosine is adjacent hypotenuse, and then tangent is opposite adjacent. When do you use it? Well, the big one is when it's a right triangle. That's really the only limitation you have. As long as it's a right triangle, trig is your way to go. So whether it's identified or you find this, then you are good. Okay, also don't forget, if you have a right triangle, you also have in your toolbox Pythagorean Theorem. That piece is in there as long as I know two sides of the triangle. I don't need to go trig again, I can do Pythagorean Theorem. So keep that in mind too. But the big thing for trig, if it's a right triangle, trig is your best bet. Next one, law of sines. The big piece that tells you you're going to use law of sines is if you have a side and opposite angle given, and obviously something else and another side, but the big one is that you have those given. So an example of that would be if I do this, so let's say this is, I'm just making up something, 50, and let's say this is 12. Having this relationship, remember, that given, I need to have some kind of ratio, so I'd say sine 50 over 12, and then I can set that equal to something, whether it be, it's one more thing, so say this is another, I don't know, 55 degrees, so then I can find whatever I need to after that. But side and opposite angle are the big piece. And I guess if you want to be really touchy about it, has to be a non-right, would make the most sense. Okay, if it is right, then you might as well just use trig. Okay, so the sine and opposite angle. Law of cosines, the big piece, or the when you know you're going to use it. If you have one or less angle given, okay, and that would also mean it also has to be and it was also a non-right. This is our last option for law of cosines. If we don't have to use it, we won't. So there's two combinations of things that tell you that if I have three sides, which means I have no angles, right? So there's the less angles. So side, side, side. Or if I'm given kind of this side angle in between side, that setup, there's your one angle. So these two combinations where I have a side angle in between, a side and a side and angle in between, that'll say law of cosines, or three sides, that'll be law of cosines. Okay, so that's kind of your general rule of thumb with when I'm using what. Okay, so let's give ourselves a little bit of practice. Okay, so our job is we're going to find all the missing sides and angles. Why don't you go ahead, see, are you going to use, based off this, are you going to use trig? Is it a right triangle? Are you going to use law of sines? Does it have an angle and opposite side given? Or are you going to use law of cosines? Try it, solve it, find angle A, angle B, and then side AC. Find those three things. 3, 2, 1, go. Okay, when I look at this, here's what I see. I see that relationship, so that means law of sines is going to be what I start with. So sine of 47 over 14. Because I have this 10, I'm going to have to solve for angle A first, so I'm going to call that sine A over 10. Okay, I'm finding an angle, so I got an inverse. So I'd end up doing sine inverse. All this would be 10 times sine 47, 14, plug it in, I get angle A equal to, and if I round a little bit, 31.5. Now, I can find angle B without doing any work, meaning I know this, the sum of interiors is 180, so I can find this one to be 101.5 if I just subtract that. So now I found my two angles. Now I just need this last side. We'll call that x. Well, I can keep law of sines, so I can still use sine 47 over 14, but now I know what the angle is that I'm looking to have a relationship with here, and x. Okay, so multiply 14 times sine 101.5 divided by sine 47, and you get x equal to, in this case if I round, 18.8. There you go. So I know what I had to start with. I knew that. I knew I had to use law of sines because I had that piece. And I can go from there. Okay. All right. Let's try this top one. Now I'm gonna have you go in a certain order because I did find out, and I'm still trying to figure out why. If you go in a different order, you're gonna get something weird that's not gonna make a lot of sense. So do this for me. I'm gonna at least give you the order. You have to find xy first. So find this one. We'll call this x. Find that first. Then, if you would please, find this angle second. I'm actually going to change what this says. Call that z. Okay, so find z first and then find angle x second. Just for sake of keeping it honest, I'll explain why, but for now. Find angle z, find side z, then find angle x, and then you can finish by finding angle y at the end. Try it out, see what you get. 3, 2, 1, go. Okay, well, to start with, because I have this side, angle, side relationship, that means law of cosines has to happen in order to find z. So if I go z squared, that means I'm going to go 22 squared minus 2 times 12, 22 cosine of 25. All that goes in, right? And I get z squared equal to 149. I'm going to round a little bit, but you probably got a little something more exact on your calculator here. Take the root, and I get z equal to, it's like 12.22 something. So we'll go 12.2 there. Now remember, once I do law of cosines, now I have this at 12.2. Now I can switch that because now I have this. I can change to law of sines. And again, I'm going to find x first. And the reason is if you try to solve for y, you're going to get a value that doesn't make a lot of sense. And here's what I mean by that. 22, since that's the biggest side, this should be the biggest angle. But if for some reason, and I'm still trying to figure out why, if you try solving for y right now, you're going to get some very small, you're going to get like 46. And then that means x is going to be the biggest angle. I don't know why. So solving for x, we get, in this case, let's see, so we got to use, again, we can use law of sines, sine 25 over 12.2, and then let's go sine of, I don't know, right, sine x, and then do that over 12. So that means we're going to take the sine inverse of 12 times sine 25 over 12.2. Plug, plug, plug. Okay, we put that in, make sure we hit the inverse. I end up with x being 24.6, right about, which means I take 180 minus the 2 that I know, and then I get 130.4, which makes sense, and that's for this angle. That's for this angle. So there's that. All right. Last one here. Well, last one for just the triangles here. We're going to do a couple word problems, 2 word problems, and call it a day for us. So find them, doing the next one down here, find the missing sides and angles. Remember, are you using trig, law of sines, law of cosines to start? Try it out. 3, 2, 1, go. Excuse me. All right. 60, 70, 80. This ends up being a 90-degree angle. So, trig. Okay, it doesn't matter which one you do. I'm going to go from 28. Why? I don't know. I'm going to find this side. So that means I got to do opposite adjacent. So that's tangent. So tangent of 28 goes x over 12, which means I do 12 times tan 28. So x equals, what? About 6.4. Now, I could do, if I'm going to find this, let's call this y. If I want to do this, I could use law of sine or cosine or whatever like that. Or, because I know 2 sides, I can do Pythagorean Theorem. So 12 squared plus 6.4 squared, and all that would end up being rooted. Either way, I'll end up with about 13.6 when I do that. Okay? So here we knew this was 90 degrees. There's our first angle. Here's our side that we found. You could have found either one. You could have found the hypotenuse first or that opposite that I found. And you could have used 62. Would have given you the same thing. Okay, so you got a little bit of freedom there. Okay. All right, let's get into some kind of some word problems here to see if you can make your triangles here. So a triangular walking course has two sides of length 230 and 360. The angle in between is 38 degrees. Find the perimeter, which means add them all up. So you're going to have to draw a quick picture, figure out how you can use trig, law of sines, law of cosines. You only have to solve for one thing, and then find your perimeter. Try it out, see what you get, and come back and check it out. All right, so it doesn't matter how you draw it, but what you're going to end up with is, I'm going to put 360 here, 230. Doesn't matter what combo, but in between you're going to have 38. So either way, I'm looking for that, right? And because I have a side angle side, that means law of cosines. So I've got x squared, 230 squared. This is the nice one. I can just plug it in once I got it. 230, 360, cosine of 38. All that goes in. My x squared ends up being right around 52005.4-ish. Remember that obviously doesn't make sense, so you need to root it. 228. I'm going to just put a 0.05. Let's make it as exact as we can. So this one added together give me perimeter. So my total perimeter, we'll call that P, is 818.05 feet. Somebody might say, well, what if I got 818 or 818.1? Hey, totally fine. Got a little bit of range there. But you should be right in the 818 range there. Okay. Last one. Let's see if you can figure out what the picture is going to look like. I think the wording gets a little bit messy, but I think you can do it. So try it out. See if you can figure out what the things look like. If you're not sure, try and draw the picture before you start. And then play the video and I'll show you the video. I'll show you the picture and then you can go from there. But try it out. All right. So I'm going to put, let's just go Glad. It doesn't matter. So Swarovski, Glad, Lynn. So we're all next to each other with that. We know that Glad is 40 feet away from me. So that's here. And 48 feet away from Miss Lynn. Now the wording here, the angle between Mr. Swarovski and Miss Lynn is 43 degrees. Well, that would mean this angle between us, excuse me, is 43. So I'm looking for how far apart we are here. Well, side angle side would say law of cosines. So I got x squared equals plus 48 cosine 43. All that goes in. I get x squared equals 1095.6. And then x, when I take the root of that, gives me 33.1. There you are. And that would be what? Feet. There you go. Okay, so all we're doing is that from our pieces here, we're saying here's our situation. What do we use? Trig, law of sines, law of cosines, and then we solve accordingly. Okay? Now, what do you need to do here for the remainder of the time? You have page 40 through 42. That would give you 6, 7, 8, 9, 10, 13 problems to play around with. The first chunk, you're not solving for everything. You're solving for the indicated value or variable, whether that's an angle or side, so pay attention to that. And then the last 3 problems are word problems to have you try out. So again, but it all comes back to what are you going to solve with? How would you solve? And then answer accordingly. Okay? Other than that, I hope you guys have a great day. I'm hoping to see you Friday. Make sure you stop into that Zoom. We'll come and see each other, and we're going to actually get our project started. So give it a shot, page 40 to 42. I apologize in advance. For whatever reason, I cannot locate the solutions for this at the moment. So, and I'm not at school, so I can't really copy anything right now at my house. So, bummer. But try your best, work with some partners, get some practice in, and we'll talk about this Friday. Other than that, have a good one, everybody.